Welcome to Robinson Fans Incorporated. Our company was founded in 1892 by Samuel Robinson, an immigrant who had been a master mechanic for a coal company in England. After arriving in this country, he began working for the Pittsburgh Coal Company as a designer and eventually advanced to plant superintendent. During his time there, Robinson devised and implemented a number of improvements in coal handling equipment. Later, Samuel's son, J.R., a mechanical engineering graduate of Cornell University, joined him in working at the company. At the time, the mines were using only natural draft ventilation, which allowed air in through holes that were drilled in the surface above. However, because the methane gas in the mines was too heavy to rise, it would accumulate beneath the ground and often cause dangerous explosions. J.R. Robinson solved the problem by inventing an air-moving device that forced out the gas. That was only the beginning. Since that time, generations of the Robinson family have expanded the operations of this company, which now designs and builds pre-engineered and custom-designed heavy-duty industrial process fans for the power generation, steel, cement, coal, chemical, fertilizer, mining, thermal treatment, and pollution control industries.
Hi, I'm Carl Steibel. Today, Robinson is recognized as a leading manufacturer of industrial fans worldwide and is known and respected as well for its engineering, quality, craftsmanship, and reliability. Robinson Fans now operates out of 4 strategic locations: Zelienople, Pennsylvania, Lakeland, Florida, Salt Lake City, Utah, and Abilene, Texas. We manufacture new fan products and offer complete repair and replacement service for the existing fans of any manufacturer. At Robinson Fan Service and Equipment Company in Trussville, Alabama, we provide on-site repair services. Robinson Fans also has independent manufacturer sales representatives located throughout the United States and internationally. Robinson Fans Quality Management System is certified to ISO 9001-2008 standards. At Robinson Fans, we are in a constant state of evolution as we continue to develop new products and improve upon existing applications. Our dedication to consistently providing products and services that exceed our customers' expectations helps us to attain our goal of 100% customer satisfaction. Now let's take a tour through our Zelienople facility, where you'll see the meticulous processes that help us to achieve that objective.
Because all businesses, facilities, and situations are different, our sales and engineering teams assess each customer's individual needs and custom design a fan for an application to meet them. Among the many things that will influence the design of its components are the load requirements, stress factors, and environmental conditions in which the fan will be operating. The fan rotor stresses are determined by finite element analysis and thermal effect analysis. We design the shaft according to stress, rapid temperature change, and critical speed considerations. Pedestal supports for the rotor and shaft assembly are built to meet the dynamic load requirements throughout the range of operating speeds. And our fan casings are designed to accommodate the forces from thermal, structural, and dynamic loads. Bearings are selected for each specific application. We also provide our customers with recommendations on structural foundation and soil stiffness requirements that must be met in order for our equipment to operate as intended. As part of our personalized service, we assign a project manager, who is the customer's main contact until the job is complete and the product shipped. To assure quality and accuracy, we create a document known as a job traveler, which contains specific instructions for every stage of the manufacturing process, as well as the quality control requirements. The job traveler accompanies the work order on each step of its journey through our plant, as the fan goes from drawing to completion. As the job traveler and the customer's order traverse each department and quality control checkpoint, the employee performing the work and the process supervisor must sign off on the completed process before it moves on to the next process. The computerized nests for components that will be fabricated are sent to our burning machine operations, where, after reviewing the instructions, dimensions, and material requirements, our technicians will burn the components to the specifications. All of the components are labeled with the job number and then sent to the layout department for forming and fitting before the welding process begins. As you can see, our facility includes heavy-duty cranes, which range in capacity from 5 tons to 50 tons. We also have many jib cranes to provide safe and quicker operation at individual process stations. Our welders of rotating parts are certified to AWS D14.6 specification for welding of rotating elements of equipment. Our welders of stationary parts are certified to AWS D1.1 procedures, and our quality control inspectors are qualified to Robinson written practice for rotors and stationary components. The rotor butt welds then undergo ultrasonic or radiographic inspections as required by our engineering standards or our customer specifications. We also perform visual and dimensional inspections before the rotor is balanced. Rotors and shaft assemblies are dynamically balanced on our Schenck balancing machines to AMSI S2.19 grade G2.5 standards. These machines can accommodate rotor assemblies of up to 180 inches diameter and 100,000 pounds. Depending upon the material from which they're constructed, other rotor components will have ultrasonic, radiographic, magnetic particle, or liquid penetrant inspections. Stationary parts also receive visual and dimensional inspections after welding. In our state-of-the-art laboratory, our research group performs air performance and sound testing for all product designs before introducing them to the marketplace. We are a charter member of AMCA International, and all tests, whether full-scale air performance tests or model application tests, are executed to AMCA Standard 210. In many cases, we also perform a critical non-destructive test that determines the natural frequency of each component to ensure that the rotor will operate safely within the RPM speed envelope for the application. Our lab and engineering service group has the capability to provide computational fluid dynamic modeling for customer applications to optimize the system's connections to the fan, which optimizes energy savings. When an overspeed test is needed, it is performed by several technicians who install the rotor assembly in our laboratory test enclosure, which is designed to reduce the power consumption at a specified overspeed requirement. This test will verify the structural integrity of rotors rated up to several thousand horsepower. During the test, the technicians monitor and record the fan's speed, power consumption, bearing vibration and temperature, circulating oil or water temperature, and the internal pressure and temperature of the test enclosure. Once the fan reaches its test speed, it is locked in to run at that speed for an agreed time duration. After the testing is completed, the rotor assembly welds are re-inspected with the same non-destructive methods used before the overspeed test to confirm that they meet all of the welding quality requirements, and the results are documented. The unit then goes through the final inspection process and is prepared for shipment.
Relationships with our customers are important to us. We encourage you to visit our facilities. Your visit may be during the design and fabrication of your specific order, or just a general visit. Our inspection and testing processes are documented and copies are available upon request. We also ask that you visit our website for application and product information. We consider each customer order an opportunity to meet our commitment of customer satisfaction.